Good morning, everyone. Welcome to the third in Digi International series of EMEA-oriented webinars this week. Every day this week, we've been conducting webinars across all of our product groups. Today, following on from Tuesday's session about our XBRF modules, we'll be covering our ConnectCore IMX-based system on modules. Next slide, please. As always, there is the facility to ask questions. You're free to ask questions at any point in the webinar, and we will address them all with the answers during the Q&A session after the content has been presented. You can either email us using digi.webinars@digi.com, or if you look in the GoToWebinar menu, you'll see there is a questions facility, and you can type in questions to the team. The presenters today, myself, Ron Singh, I'm the Director of Distribution Sales at Digi, but we have Andreas Burkhardt, who's the Principal IoT Technology Manager, and Paul Norbury, who is Director of Sales for the Embedded and RF Group. So, for those of you who may not know Digi that well, Digi International is a US-based IoT technology and solution provider. In Europe, we have multiple sites and staff across the continent, and our product offering falls into these three segments. We have Digi International's box product portfolio, which includes a range of cellular routers and gateways for enterprise, industrial, and transit applications, out-of-band console management products, and solutions for USB over IP. We also have Digi International's OEM and embedded and RF products, which includes, as we will present today, our range of ConnectCore system on module and single board computers, and also Digi International's XB range, our footprint compatible RF modules for 2.4 sub-gigahertz and cellular connectivity, which we presented earlier this week. And if you missed that presentation, you will actually be able to catch it on our website in its entirety. And we also have Digi International software suites. We boast a plethora of software-based platforms and tools for development, deployment, and management of multiple IoT hardware products. And finally, spanning all of our products, we have Digi International TrustFence, our proprietary security framework, incorporating several aspects of security from secure boot to anti-tamper. TrustFence is over-the-air upgradable and assists many of our customers in removing the barriers of having to develop and manage IoT security measures themselves. So I'll now hand you over to Andreas, who will present the rest of the presentation.
Thank you, Ron, and welcome to everyone on our webinar. Today, I'll be covering the following topics. First, as a short intro, I'll talk about the complexity of developing IoT solutions. I'll introduce you to the Digi ConnectCore SOM solution offering, and we'll take a look at our current SOM product portfolio. We're closing off with application examples, and Paul Norbury will highlight a few ConnectCore customer projects. So first, developing an IoT solution is a difficult and complex project. When Cisco surveyed nearly 2,000 companies, they found that 60% underestimated the complexity of building IoT solutions, and 75% of projects were considered a failure. Among the top reasons cited were schedule and budget overruns, integration complexity, and the lack of internal expertise. A more recent study by Microsoft showed similar results, with complexity and technical challenges at the top of their list. Digi's ConnectCore offering reduces this complexity significantly, paving the way for successful IoT product development. So there are different options for embedded system design, starting from the far right, designing a complete device with a system on chip from scratch with very high complexity, complex layout requirements, high-speed signal routing, software integration efforts, including the development of the board support package, its maintenance and so on, is a high risk, long time to market and high development cost endeavor. You're better off with a system on module or even a complete single board computer. These are integrated systems, significantly reducing the hardware and software development complexity, the risk and development cost in your product design, providing a much faster time to market. It's possible to grow the expertise internally for chip-level designs, but it's important to consider the opportunity cost and whether that's really where you want to focus your R&D resources. SOMs and SBCs accelerate your time to market easily by 6 to 18 months. There are several strands to the argument of buy versus build. Component count is often cited as a counter-argument. BOM component cost is always lower than SOM price, but there is the hidden cost to add. For example, managing that high component count being sourced from multiple vendors is not cheap. Manufacturing cost, putting all those components on the board, and managing component obsolescence. Arguably, the most significant yet hardest to quantify factor is the design effort and cost. For hardware design, there's a lot of time and cost consumed in component selection, PCB layout, test, board respins, etc. On the software side, there's the OS selection, driver integration, security considerations, etc. And there's the process engineering, refining the final design into something that can be productized. Also, there are approvals or certifications required, particularly in wireless certifications. That's a complex task. And finally, managing any changes in the above factors across the whole life cycle of the final product. Our mission at Digi is to simplify and accelerate the development, deployment, and management of secure connected products, so you can save time, money, and risk and focus on your core competency instead of embedded wireless design complexity. Today, we're talking about our ConnectCore offering of intelligent, secure, connected system on modules. But I also want to mention our XP products, providing simple, very flexible, secure wireless connectivity options. The XP modules are usable standalone without any additional microcontroller or host processor, or they can be connected to other computing devices, such as a ConnectCore SOM, providing additional wireless connectivity options for your products. XP provides broad support for leading IoT standards like LTE cellular, mesh networking, and long-range sub-gigahertz. XPs are easy to use and pin compatible, making it trivial to update a product as new technologies emerge or to support multiple protocols across a range of products. But now let's dive into our ConnectCore offering. Digi ConnectCore is more than just a hardware offering. ConnectCore is a complete SOM solution, including a full security stack, BSP, board support package, and operating system software. Development tools, options to integrate with cloud services, and a full remote management service called Digi Remote Manager we are providing. We are Gold Partner of NXP and use different i.MX processors on our SOM platforms. They're designed for industrial and medical use for 10+ years longevity. Building secure products is hard, but keeping products secure is even harder. The challenge of maintaining device security increases for embedded industrial and medical applications for a number of reasons. Long product life cycles give hackers more time to exploit devices before they reach the end of their life. Many embedded devices are deployed in remote places outside of traditional IT networks and security tools. Additionally, many systems are battery powered and not always connected, making them more challenging to monitor and update. And industrial applications are increased targets for cyber attacks due to their scale and mission-critical nature. Our approach is proactive. We are providing trust fence as security framework so customers can start with built-in security. Due to the complexity and skill set required, many companies fail to properly implement security. Trust Fence is a device security framework that simplifies the process of securing connected devices. So you don't have to be a security guru to implement features like secure boot, firmware updates, encrypted file system, or certificate management. At its core, Trust Fence is built on the foundational security features of NXP i.MX, combined with a hardware-based secure element and software extensions in U-boot, the Linux kernel, and user spaces. In addition, we understand that designing secure products is just the first step. Trust Fence is scalable and upgradable, and to support long life cycles, Digi Security Office addresses common vulnerabilities and exposures, including ongoing monitoring, alerts, and notifications. On the software side, we are providing a complete open source Linux solution based on Yocto project. We start by pulling in the latest releases from upstream projects like U-boot and the Linux kernel, and also integrate NXP's BSP. On top of this, we add customizations for Digi SOM platforms, as well as out-of-the-box software extensions to help accelerate your software development. Some examples include Digi's Trust Fence security framework, wireless drivers, secure firmware updates, third-party cloud integration, and low power optimizations to enable things like ultra-fast wake-up from low-power suspend the RAM mode. We deliver pre-compiled software development kits, SDKs, and toolchains, plugins for popular IDEs, and comprehensive online documentation. But most importantly, we perform comprehensive system validation on our SOMs and maintain the software over time to incorporate important updates and security patches. We provide the same level of integration on Android than we do in Digi Embedded Yocto Linux. The API extensions, APIX, are certainly very interesting in Android. Standard Android does not provide any APIs for embedded industrial interfaces, as for example, a CAN controller or RS485 or even Ethernet. We have implemented APIs to bring those embedded interfaces to the same Java API level than the other standard supported interfaces. A Java application developer, an Android application developer, now has one common Java API layer also for the embedded industrial interfaces, eliminating the need for them to drill down into the C++ layers to get the information from these industrial interfaces. This is a key advantage and makes Android really usable for embedded devices. Let's take a look at a few of our development tools. The highlight is our Digi ConnectCore Smart I/O Mux. Digi Smart I/O Mux is removing the complexity of pin assignments in your design. As you probably know, every processor and SOM pin can take multiple functions. The designer needs to map the interfaces required in their product to the SOM pins. This can be a very complex task. NXP provides Excel spreadsheets for the pin functions of the processor, and a lot of the information is buried in the processor hardware reference manual. It's not so easy for many developers to get this right. Smart I/O Mux provides a graphical user interface where you can select the interfaces you need in your product, and the tool maps these automatically to the available pins on the SOM. It further lets you configure the electrical values of the individual pins to meet your exact interface requirements. And at the end, you can export a table for the schematics designer, and the tool even provides Linux kernel configuration file snippets, the device tree, to configure the kernel for your custom hardware design. This saves time, helps to avoid errors in your hardware design, and reduces risk in your project. And quite new, we are also providing hardware design guidelines and checklists. From the many design reviews we did at Digi, we did collect common errors and issues and are sharing these in our design guidelines to help customers to avoid errors in their carrier board design and ensure a functional quality design featuring the ConnectCore SOMs. These guidelines also include RF guidelines and help to bring up customer boards. If more design support is required, Digi is also offering wireless design services for custom hardware and software development, as well as certification support. We are further providing a vast collection of design files, speeding up the development at our customers. For example, many customers use Altium Designer for their hardware designs. We provide a full Altium Designer project of our SBC boards and development boards as a starting point for custom carrier board development. Customers can simply remove the interfaces they do not need and finalize their custom carrier board quickly. We provide reference schematics, development board, bill of materials, mechanical drawings, 3D models, and even boundary scan files for our SOMs to enable customers to set up a high-end professional production process for Digi SOM-based assemblies. On the cloud side, we are providing Digi Remote Manager. This is our scalable enterprise-grade network management service. Besides secure remote firmware updates, you can monitor and configure your devices through Digi Remote Manager in the field. You can access data from your edge devices and integrate that data into other business applications through open APIs. Digi Remote Manager can also be connected to other cloud platforms. It's actually a common use case that customers manage devices with Digi Remote Manager and have a single connection from Digi Remote Manager to, for example, Amazon Web Services or Microsoft Azure or other cloud services for further analysis of their edge device data. ConnectCore is also integrated with Amazon's and Microsoft's cloud services and the connectivity to these, as well as their edge compute capabilities. That's fully supported within the ConnectCore offering. In order to deal with increasing system complexity, our approach is to deliver even higher levels of hardware and software integration. Starting with hardware, here's what a typical Digi ConnectCore SOM looks like. We start with the NXP i.MX application processor. Next, we add a secondary Cortex M0 microcontroller to assist with advanced operations like power management, system reliability, and temper detection. We also add a dedicated secure element to enable additional layers of security. We add a power management IC, high-speed memory, and pre-certified dual-band Wi-Fi and Bluetooth connectivity, complete with an RF shield. When we flip the SOM over, you will see Digi's innovative SMT Plus form factor. For simple applications, the castellated pads around the outside edge can be used. For more complex applications, the full LGA footprint can be used to gain full access to the processor without any sacrifices. ConnectCore is a very scalable solution, providing options in terms of processor cores, memories, display and multimedia support, as well as connectivity options. On the connectivity side, all Digi SOMs have a Wi-Fi and Bluetooth option. We provide global certification for the wireless interfaces. Both 2.4 gigahertz and 5 gigahertz Wi-Fi are fully certified for the Americas, for Europe, Japan, New Zealand, Australia, and more. The Bluetooth interface is fully approved by the Bluetooth Special Interest Group, and you get QDIDs for the hardware as well as for the software stack. So you only need to list your final product with the Bluetooth Special Interest Group, with no additional measurements or approvals needed. In summary, Digi ConnectCore enables you to focus on your core competency. We at Digi provide the high-speed hardware design, a fully validated BSP, driver and operating system software, complete device security, pre-certified wireless connectivity, and we maintain the hardware and software throughout the product lifecycle, reducing complexity, risk, and effort for a faster time to market of your products. So let's look at the ConnectCore SOM portfolio next. Our range of SOMs scales from a single core Cortex-A7 on the lower end to dual or quad-core Cortex-A53 in the mid-range and the dual or quad-core Cortex-A35 with advanced multimedia capabilities and many industrial interface options on the high end. All of these are specified for industrial temperatures at -40 to +85 Celsius. And all of them provide that option for an integrated pre-certified Wi-Fi and Bluetooth radio. Our ConnectCore 6UL SOM is based on NXP's i.MX 6UL processor. It is equipped with industrial SLC single-level cell addressing, NAND flash to support long lifetimes of a product. The SOM carries our Digi microcontroller assist, providing extra functionality and robustness to the system. Just to recap, the microcontroller assist is an additional Cortex M0 Plus microcontroller, enabling a very low power mode for the SOM, as well as additional features like an external watchdog, security temper detection pins, and peripheral extensions like additional UARTs, GPIOs, ADCs, and others, fully usable from the operating system through a Linux multifunctional device driver. The SOM provides an option for 802.11 ABGN AC, 2.4 and 5 gigahertz Wi-Fi, as well as Bluetooth 5.0. It supports our Trust Fence security framework and Digi embedded Yocto. For the ConnectCore 6UL, we are also providing a single board computer. This is a Pico ITX form factor board, which is fully certified, so it can be deployed to the field, and it is specified for industrial temperatures. The SBC provides many interfaces, including a PCI Express mini card connector with a cellular SIM socket attached to it to enable cellular connectivity out of the box. It also supports a socket for the Digi XB modules to provide additional wireless connectivity options such as Zigbee, our Digi Mesh, or LTE-M and NB-IoT. The SBC can drive an LVDS display with touch for graphical user interfaces. That SBC is included in our ConnectCore 6UL development kit. And you get full schematics as well as an Altium Designer project for it to enable quick modifications and support for custom carrier board development. Following our Get Started guide, you are up and running within a few minutes, and you can start creating your first applications with our Eclipse-based Digi application development environment for Linux. Moving on to our mid-range SOM platform, the ConnectCore 8M Nano. We have just launched the ConnectCore 8M Nano a few months ago at Embedded World in February, just shortly after NXP has launched the i.MX 8M Nano processor. But it's already a matured platform. The i.MX 8M Nano processor shares a lot of the peripherals with other members of NXP's i.MX 8M family. The family has been around for a while, hence we have a very complete and robust BSP from the start. A highlight of the ConnectCore 8M Nano is its very powerful GPU to enable high-end graphics, but also machine learning applications, which are leveraging the GPU for image recognition or other tasks. Also, on this SOM, we provide our Digi microcontroller assist, adding the additional features I mentioned before. And there is the option for an 802.11a BGN AC, Wi-Fi, and Bluetooth 5.0 interface. Since the i.MX 8M Nano processor does not provide a native CAN interface, Digi is providing a reference design for connecting a CAN controller on the carrier board. This is fully supported and maintained in software, so our customers have a CAN option with this product, which is maintained by Digi. The ConnectCore 8M Nano development kit provides a full development board with all the interfaces brought out on the board, as well as many additional options. For example, you have the option to connect an LVDS and an HDMI display. Cameras, audio is on there, and there are 2 XB sockets to extend the design with our XB wireless capabilities. We also provide the PCI Express mini card slot to support cellular modem integration. And this board has the CAN FD reference design I just mentioned. Also, for this board, Digi is providing a full Altium Designer project and all the other supporting documentation to speed up custom carrier board designs. Our high-end SOM is the ConnectCore 8X based on NXP's i.MX 8X processor family. We are providing a dual and a quad-core variant of this SOM. The SOM supports LPDDR4 memory, enabling very low power applications with best-in-class suspend to RAM power consumption, required for power-constrained devices in battery or solar-powered applications. Besides the very powerful GPU, this platform is also supporting a video processing unit, a VPU, for hardware-accelerated video encoding and decoding. The Digi microcontroller assist is included, as well as the option for a Wi-Fi interface. On this SOM, we're supporting a MIMO 2x2 MIMO Wi-Fi interface, combined with Bluetooth 5.0. Additional to the Digi embedded Yocto Linux, we are providing Digi embedded Android for this platform. And both Android and Linux have full support for the TrustFence security features. For the ConnectCore 8X, we're also providing this single board computer. The board provides 2 gigabit Ethernet connectors, dual LVDS display capabilities, and the Digi XB module header to add additional wireless communication options. There's also the PCI Express mini card connector with a SIM socket attached to it for cellular integration. And there are different camera options on this board, plus a USB 3.0 C-type connector. Customers are also able to connect additional peripherals through extension header rails. This board is fully certified and is specified for industrial temperatures at -40 to +85 Celsius and can be deployed to the field. The ConnectCore 8X development kit includes the single board computer. Get started guides are provided for Linux and Android, guiding you through the setup steps and through application as well as full system development. Digi is also providing an LCD accessory kit featuring a 10-inch LCD including a touch screen. This kit can be connected to all of the previously mentioned single board computers and development kits. The LCD and touch are fully supported in our software, and they work with our default software images out of the box. To summarize, Digi ConnectCore features a range of scalable system-on modules and single-board computers built on NXP i.MX. Our solutions range from single-core A7 up to quad-core A35 and A53 processors with a wide range of multimedia and connectivity options. By leveraging our common platforms and software environment, you can quickly integrate ConnectCore into your full range of products with varying levels of performance, features, and price. On this slide, I'm providing links for further reading. On top, you'll find a link to our embedded documentation portal. This is worth checking out. It's a well-structured, easy to use, and very complete documentation portal covering our hardware, software, trust fund security framework, remote management, cloud integration, and even the setup of the manufacturing process when moving to production with a Digi SOM-based design. I'd also like to highlight the link to a recent webinar we have conducted together with NXP talking about embedded design challenges, which is available on demand on the Digi website. So this is a screenshot of our documentation portal, and the link is there below. We have all the SOMs grouped here from the 8M Nano, the 8X, the 6UL, but also the 6 and the 6 Plus a little further below. And we are covering the Yocto Linux platform, hardware, tools, Android for the 8X. It's all in one portal here with links to the tools and everything. So you have it all in one place, very easy to use. So let's look at a few ConnectCore application examples. We see a lot of projects in electric car charging stations. The ConnectCore 6UL is often used as a communication controller in these stations. It can support additional functionality, which is usually supported by higher priced legacy components. So it enables the manufacturers of these charging stations to cost reduce their products. Pre-certified Wi-Fi and out-of-the-box cellular support obviously helps with the communication interface implementation. And the ConnectCore 6UL is superior in terms of power management and power consumption, which is a key requirement in electric car charging. Security is another key requirement for these stations. Being in the public and dealing with financial transactions, security is really a big topic for these manufacturers. With trust fund security building blocks and a hardware secure element on board of the ConnectCore 6UL, this is a perfect fit. Another good use case for the ConnectCore 6UL are telemetry data gateways. Being an industrial rated SOM, which has gone through extended environmental testing, such as vibration, shock, halt, high accelerated life cycle testing, it's designed for use in harsh environments and a good fit for transportation applications, for railway and agriculture applications. In these applications, the ConnectCore 6UL usually collects data from connected peripherals and sensors and transmits them over Wi-Fi while the vehicle is in the depot or in the dock, or transfers that over a sub-gigahertz radio or cellular link to a monitoring backend station. Let's have a look at some examples with display capabilities. This mobile citizen service kiosk is a very feature-rich product. It can be used as a voting terminal at border controls or similar use cases. This supports two displays, one for the operator and one for the client. And there are many peripherals connected, like cameras, scanners, a card reader, audio, microphones, and it's using up a majority of the 474 pins we are providing on our SMT Plus LGA footprint. Also here, security is key, and this is well supported by the Trust Fence security framework as well as the hardware secure element. A more industrial type application is this safety and control device for machinery and construction. This is a common use case. Operated in harsh environments, these devices need to provide relentless reliability and bulletproof performance. The CAN bus is often used for vehicle communication, which we support on the ConnectCore 8X and the 8M Nano platforms. With that, I'd like to hand over to Paul Norbury to highlight a few ConnectCore customer projects.
Thank you, Andreas. And good morning to everybody. Today, I'd like to share with you some of the customer projects Digi have worked on using the ConnectCore family of devices, showing you the diverse nature of the applications we work on within many different markets. The first example we see on the left-hand side here is a gas detection monitor for both industrial and firefighting applications, providing maximum safety in some of the most demanding situations. The detector also has a motion sensor, which will alert others to know if the user becomes immobile, which, as you can imagine, in a firefighting situation is absolutely a prerequisite. The next one we see is a lung ventilation product. This helps provide patients with optimal ventilation support during transport over land, sea, or in the air in some of the most challenging environments. This particular product is also endorsed by the US military and NATO. Moving on, as Andreas just mentioned, electric vehicle charging stations. We have seen more and more vehicles on the roads, electric vehicles, and this comes with a need for charging stations. We have many customers building electric charging stations today. These can be small wall-mounted systems for home use with both single and dual sockets, or robust charging pillars that can be used in car parks, supermarkets, and highway service stations. This is an ever-increasing market and one that is well served with the Digi ConnectCore modules. On the right-hand side, we see the nurse call system. These units now have become the hub of many hospital wards, giving nurses updates and alerts when patients need help and support. And more recently, as we well know, these have been well needed. Moving on to telematics. This particular one is for a gate monitor within a trailer. These are highly versatile CAN devices that are advanced with advanced telematic applications that give a variety of vehicle interfaces, providing preventative vehicle maintenance planning, remote vehicle diagnostics, temperature monitoring, and driver logs, i.e. the number of hours driven by any particular driver. And lastly, but not least, this is an endoscope. This provides virtualization of airways and vocal cords, which has been absolutely needed recently. The dual displays and video processing are absolutely paramount. The camera is located at the tip of the scope, and then images are presented on the displays that can be clearly seen by the medical staff. As you can see, we work on many different and very diverse projects. So just to recap, developing IoT solutions. According to the recent survey, as indicated by Andreas earlier, 60% of these companies underestimate the complexity of building IoT solutions, and they suggest that 75% of these companies will fail. This, I believe, is where Digi and Digi's ConnectCore modules can really help. As stated previously, our mission at Digi is to simplify and accelerate the development, deployment, and management of secure connected products. And with that in mind, we provide a faster time to market, longevity of supply, 10 to 15 years, including 3 years of warranty on our modules. Regarding software, we provide a free of charge BSP, board support package, for both Linux, Yocto, and Android, which is easy to use, it's feature rich, it's fully validated and secure. But more importantly, it's maintained by Digi, so you don't have to. Thus saving time, money, and risk, which then allows you to focus on your core competencies. We also provide pre-certified Wi-Fi, ABGN and AC, plus Bluetooth 5.0. Excuse me. We have both software and hardware security. Software through TrustFence and hardware via a secure element on most of our ConnectCore modules. Andreas mentioned our enablement tools. The Digi IO Smart Mux, providing simplified hardware pin configuration, hardware design guides, checklists, and schematic reviews. Also, we have the Digi Remote Manager, which includes cloud integration for Amazon AWS, Microsoft Azure, and also gives over-the-air upgrades with alarms and alerts. We have development kits, as he said, for all our modules that are now freely available on all our devices. Thank you very much indeed for your time this morning. Now I'll hand back to Ron for any questions.
Good morning, and thank you, Paul, and thank you, Andreas. As mentioned, if you have any questions, please use the email address digis.webinar@digi.com, or you can use the questions facility, which is on the GoToWebinar menu facility, to send through any questions. And I'll just check now to see what questions have come through. Okay, gentlemen, I have some questions for you already. What's the cost of Digi TrustFence, and are there any annual royalties involved?
Good question. I should have mentioned that. So the TrustFence security framework is completely free of charge and can be used with our SOMs completely free of charge. There's also no royalties or anything. So it's a free offering along with our SOMs. And that counts for all the tools we are providing. Also Smart IO Mux, for example, that's also free of charge.
Okay. Did the ConnectCore 6UL always have, I presume it's 802.11 AC, or was it recently added?
This was not recently added. From the launch, the ConnectCore 6UL had an 802.11 ABGN AC interface with both the 2.4 and 5 gigahertz. This was there from the start.
Okay, thank you. How much assistance can Digi give me to design my carrier board if I design with a SOM? And how much easier is that than adapting an MPU development kit board?
So we provide a lot of documentation as well as support through our sales engineering team in Europe, as well as the support group with people in Europe, so same time zone. So there's a lot of support along the SOM products to help with questions in the design process, and we have the design guidelines and all that, and we are also providing design reviews to make sure the SOM is connected right, the power rails are in place to enable the suspend to RAM and all the not so trivial modes. So that's checked by Digi. And we're also offering wireless design services, we call that. That's a group of engineers fully dedicated to custom engineering. This can include hardware designs, but also software work like driver implementation and operating system configuration and certification help. So that's available as a service from Digi. And in Europe, we further have a network of partners, design companies providing engineering services. These partners have done multiple designs with our ConnectCore SOM, so they have good expertise. They know the products very well. They have good support from our side, of course, as well. And they are also available across Europe to help with designing custom carrier boards and integrate our SOM solutions.
Okay.
So compared to adapting like an NXP development kit,
Yes.
that's a far more complicated, complex task. So, I mean, that's a full chip design with all the routing of the high-speed signals, connecting the memories and all that. Well, there's reference designs, but you still have to go through that work, and then all the bring up. And depending on the size of the company, NXP is not supporting every company. They focus on the tier ones, so it's much better to go with a SOM and get the full integration support from a company like Digi.
And if I'm correct, an MPU-based board would have at least 4 to 6 more layers than a carrier board for a SOM?
Good point, good point. So the SOM has a lot of layers. It's a complex PCB with a high-tech PCB, multiple layers, microwires, so quite complex technology. The carrier board on the other side is way simpler with just like maybe 4, 6, 8 layers. So way simpler technology, way lower cost per square centimeter. And the carrier board's usually the bigger board. I mean, you want to reduce your technology level on these to save cost on that bigger board. That's for sure.
Okay, thank you. And final question. I see the XB socket on some of the ConnectCore development boards. That's correct. We do have an XB socket. How easy is the software integration to add an XB module functionality to my design?
So yeah, we are providing sockets on all of our SBCs, single board computers, and development boards. So hardware-wise, you can just purchase an XB module and plug that in. So it's fully supported on the hardware level. On the software side, we are providing libraries to communicate with XB modules with all the standard functionality. We have software libraries to be integrated in different platforms, Linux, Android, other platforms. There's libraries for C, C++. There's a Java library to develop Java applications leveraging XB communication. There's also a Python library and some more maker type libraries, Arduino, and some others. So Embed, I think, is there as well. So you have a vast collection of libraries to integrate your application very easily, running on a ConnectCore and integrate that with XB modules.
Brilliant, thank you. That's all the questions we have, but obviously if you have any more questions, if you think about the content that's been delivered today and something else comes into your mind, feel free to contact us either through any of our social medias or through our website or direct email. And of course, if you do know of any of our regional sales managers or field app staff, please contact them directly. Thanks again to Martin and Andreas and Paul for the presentation this morning. This presentation will be posted on our website in due course. And just a reminder that our final presentation is tomorrow morning at the same time, 10 a.m. Central European Time, and we'll be covering our solutions for infrastructure management, out of band, and USB over IP. So thank you again for your time and have a good rest of the day.